Hello everyone, welcome back. Today we are going to talk about a open source library called PySPH. This is an open source framework for smooth particle hydrodynamics, but this can be used to implement a lot of meshless methods, for example DEM or generalized finite difference method. This particular software has been developed by a group at IIT Bombay, and we'll see that how we can use this particular software to write SPH codes such that we don't have to write a lot of loops, and there are a lot of methods and routines that requires you to find the nearest neighbors of particles. That's also provided by this particular framework. First of all, we'll discuss that how we can get this particular software. I'm going to talk about an easiest way. If you are new to this and you don't want to go through the process of installing everything starting from Python, I'll discuss that in this particular lecture. Let's get started. First of all, you have to install Docker. Docker is a open source tool which allows you to install a lot of softwares in a containerized version. That means you don't have to worry about installing a lot of supporting libraries that requires for a software to run. This Docker engine, it provides you a container, and inside that container everything is there that requires you to run that particular software. You have to install this Docker desktop for your corresponding operating system. Since I'm using Linux, I'll go here and install this. Depending upon my operating system, I can choose one of them. Since I have already gone through this, you can follow these steps. Remember that after installing this, you have to do some post installation steps. Make sure you follow all these steps. It's straightforward. You just have to copy paste these. Once this is done, you can close this, and then I have already created a Docker repository for PySPH. You can go to Docker repositories and then search for PySPH. You'll find a lot of repositories. This is the one which I have created. There are others as well. And this one is the original software, but this was created long back. This one is just 2 months old. You can choose which one you want to try. All of them works. Once you go here, you'll find different tags. This is the one which has MPI capabilities, and this one has just OpenMP. This has OpenMP as well. If you want this one, you can download this one, or if you want this one, you can download this one. You can copy the command here and then type this docker pull and whatever was the command. When you enter this, since this is running, let me do one thing. I wanted to show you that you need to start your Docker desktop. I have started my Docker desktop. Now if I run this, I'll get this error. Cannot connect to the Docker daemon. It is looking for the Docker desktop, whether it is running or not, because it uses that application to connect to the Docker repositories. Therefore, you have to open Docker desktop. This is how my Docker desktop looks. So these are some of the images that I have already installed. I have already loaded MPI. I'll show you how OpenMP looks. Once you do this, and then if you run this, you'll see that it will start loading this particular image. When you are running this for the first time, then it will load everything. You can see it is downloading various files, and it will download an image of this particular software. Once it has loaded, then you can type docker run it, and then this particular name of the image. So you can see the name is here, Pawnegi PySPH builds OpenMP. We have to type OpenMP here. We typed it wrong here. Now it opens a new terminal. It looks like the same terminal, but you can see there is nothing inside. But inside this particular folder, you have my test. When you run this, you can create a new directory, save test. Now you can see the test directory here, and when you go inside this, You can also see which Python. So you can see it says the user local bin Python, and which PySPH. This is also user local bin PySPH, and you can also try running this PySPH run. You can run any example. It gives you a list of examples which are already there in the PySPH software. You can see I'm running this 16, number 16. You can give some additional argument. Let's say I want to run with OpenMP, and then it will start running. Let me stop this here. Now you can see there is a folder which has been created, Dam Break 2D, and here you can change the file. Here dump VTK and the output. I can do dump VTK to dump the VTK files, and then the output directory, Dam Break. Let's see if we have all the files converted to VTK or not. You can see that all the files has been converted to VTU. So now you can open this in ParaView. Let me also tell you something about ParaView. By the way, in PySPH you have a viewer as well, but in Docker you cannot open a viewer. It's hard, it's not impossible, but it's hard to load a viewer. Therefore, we'll use ParaView since you are using for the first time. Therefore, this is a workaround. But when you are going to use it for a long time and you want to get started with this, then I'll explain the installation in your local system in the next video. Here you can download ParaView. For a relevant operating system, you can download the executable from here and then go ahead and visualize this. But here, one thing you should note that I have created this test folder. This test folder is here in the Docker. But if I exit this, all my changes will be gone. If I again go back, there is no test folder. It is gone. How to have this particular changes in our local directory? In order to do so, you have to use this particular command where you have to say that I want to have this my test folder, which is, you can see here there is a my test folder. I want to have this my test folder as in the home, and inside this I'll create this test folder. This folder will be same as my local folder, and inside that, with this I'll run this particular image. When I load this particular image, it will load this particular local folder as well. Let's see. Now I have to do cd home and test, right? And if I run PySPH run again, and with 16 and OpenMP, then it will again compile because it also lost all the compiled files. So therefore it is compiling again, and again it is running. You can see here there is a Dam Break 2D output which has been created, and now I can visualize this. Let me first convert this to VTK, dump VTK, and then Dam Break. Let me check if it is converted. It is converted. If I exit this and again load this and go to home and then test, I'll again find this, right? And since my local directory was this, therefore inside my test also I'll find this particular file, right? And here all the VTK files. Therefore if I run ParaView here and open this, let's say all the fluids and the boundaries, and open these, there was some problem. Let me delete this and open the individual VTU files. Say this one. Again there is some problem. Probably this has stopped working because this dump VTK was used in the old version, and this ParaView is the latest version. Probably there is some problem there. But you can see that how you can use this. I have a locally installed PySPH as well. Let me use that just to show you the results. PySPH view Dam Break my test Dam Break 2D. You can see how the visualizer of PySPH looks like, and if I play this, you can see that the Dam Break simulation is going on. This is how you can use PySPH, but I have not discussed that how you can visualize this in ParaView because something was broken. Let's also see if there is some other method to dump it. I'll again run this, then go to home tests and then see if there is some other version. There is XDMF version as well. Let's try to dump in XDMF version. Dump XDMF and then Dam Break 2D. Now again use ParaView to open this. Clearly there was something, but let's see if it opened. You can see here there are 9 time steps but 0 cells. So there were other versions as well. Let's try that. Let's open this only and try this. Yeah, this one worked. Let's try this one for the other as well. Now you can see it's working fine now, and here if you see pressure, you can see the pressure as well. Clearly for this particular version of PySPH, outputting this in XDMF format and then opening it using this particular reader, which is the standard XDMF reader, that works. You can use a combination of Docker and ParaView to get started with PySPH. With this, we are going to stop this particular lecture. If you like the content of our channel, then please like, share, and subscribe. Thank you.